Yeah, boy. Sputtering is a type of physical vapor deposition and is used to deposit metal onto a surface via ion impact induced vaporization of some variable deposition material. This process is usually performed in vacuum at room temperature. In sputtering, an ion gun ionizes an inert gas, which is then accelerated towards the deposition material or materials. The high-energy ion beam impacts the deposition material, causing it to vaporize and deposit onto the substrate. To alloy materials, you simply need multiple ion guns concurrently vaporizing separate deposition materials. You can control the composition by changing the ion gun accelerating voltage or by adding ion guns to the chamber. Sample thickness can be controlled by altering deposition time. The sample is located on the cathode, and since ions are negative, they travel from the cathode to anode. In this experiment, argon ions were used as the ion beam because argon atoms are relatively heavy. The argon beam interacts with two targets, one composed of copper and one composed of silver, as these were sputtered onto the substrate at the same time.
Yeah, boy! This is the Keyence VKX150 laser confocal microscope. First, turn on the laser confocal microscope and wait 5 minutes for the laser to stabilize. Next, we use tweezers to place the sample onto the stage.
Yeah, don't scratch it. Don't scratch it. Careful.
Once the sample is on the stage, we use the X and Y knobs to get the sample into view. Then, we use the fine and coarse focus dials to get the sample into focus. In the VK Viewer software, we're first going to focus our sample again. To do this, we press the up arrow until the sample is just out of focus. This gives us the upper position. We repeat this with the down arrow to get the lower position. After the two positions are set, we are ready to start the measurement and obtain an image. This is the sample with gold and silver sputtered on a silicon substrate in the VK Observer software. We have used the roughness setting and are looking at the highlighted area, with the RA value being the roughness.
In order to put a sample into the AFM, it's important to carefully open it to avoid damage to the machine. Once the AFM is open, if you would like to add a sample, just make sure it's not too large and put it onto the square holder. Once the sample is added to the AFM, carefully close the device, ensuring you do not cause damage. Here, we see the cantilever, and at the end of the cantilever is the tip, which is approximately 10 nanometers across. These are extremely small and are usually made of silicon nitride or silicon oxide. Being this small, the crystals are usually grown. The resolution of the image depends on the size of the tip. AFM involves physically moving a tip across the surface of a sample in order to follow the sample's topography. There are two modes of operation in AFM, contact mode and non-contact mode. Contact mode involves oscillating the cantilever vertically as it raster scans the sample area. Non-contact mode operates similarly, but the cantilever oscillates with a smaller amplitude, thus preventing contact with the sample. Contact with particularly soft samples, or samples of varying properties, could lead to image artifacts. Precautions must be taken to dampen vibrations, which could lead to image streaks as seen to the right here. To aid in damping, many AFM devices are set on vibration isolation tables, which use compressed air to dampen environmental vibrations. More sensitive AFM devices will also include wind covers to block air currents.